really glad to be here. As I said, my name is Rajiv Mongia. I run the user experience activities in RealSense. And so I look at this technology to kind of figure out what in the world are people going to do with this stuff. And I think the previous speaker was correct in the sense that we are really seeing a huge shift. I think we all know VR has been around for decades. And yet, in the last 5 years in particular, there have been some enormous investments. You just have to read any of the tech blogs. You can read the financial section of the newspaper. In every one of these places, you're seeing this shift towards computer vision, AR, VR in this space. Investments by Intel, Google, Qualcomm, Facebook, everybody is moving in this space, obviously. So what's really going on here? What's really changing things and changing the way by which we are looking at this, and why now versus 5 years ago or 10 years ago? And a couple things. First of all, I think we could look at kind of a little bit of history, and let's go back to biology, which is let's look at the human brain for a second, and this will become clear as to why. The brain has about 100 billion neurons inside of it. For some of us more, some of us less. The switching frequency of the neurons is about 1 kilohertz or so. And again, that's not the totality of what it takes for computing in the brain, but it certainly gives you a first order of magnitude as to kind of the processing capacity of the brain. Now, what is that processing capacity typically used for? Well, evolution has basically been teaching us to use our brains to really understand our environment. We have a sense of taste, smell, sight, hearing, and vision. And it's these 5 senses where basically the vast majority of our processing power of our brain is actually being utilized, because this really was the difference between us being eaten or us finding something to eat. So this is hundreds and hundreds of millions of years of evolution have brought us to this point. Now, what's been happening with our computer brains? Well, if you look at a little bit of history here as well, 1971, about the year I was born, you had about 2,300 transistors going at about 740 kilohertz on the chip. And so obviously not a whole heck of a lot of computing power, but we love Moore's Law at Intel. It's the 50th anniversary of Moore's Law, and I think it's appropriate to look at the fact that here in 2014, we're looking at about 2 billion transistors on a chip going at around 3 gigahertz or higher. So if you actually start doing the multiplication here, not that it's the totality of processing power of the brain, but at least you get an understanding that we're starting to actually reach a parity, order of magnitude-wise, as to the fact that these numbers are starting to become similar. There's a lot of other factors in the brain, connections between neurons and complexity of connections and so on and so forth. But to a very, very first approximation, you can see the fact that our devices are now starting to have the amount of processing capability of a brain. So what that means is that we can now process data in a much more interesting way. We can start looking into our environment a lot more. We can rely upon sensors. We can look at accelerometers and gyros and computer vision and all manner of things in order to much better understand our environment. So our devices can understand the environment, and the devices can actually understand us much more meaningful level than they ever have in the past. So what does this mean? Well, RealSense, the activity that Intel kicked off, started about 5 or 6 years ago. And really, at the end of the day, we saw this thing happening. We saw this computing capacity increasing over time. And we thought this could really have an amazing opportunity to create more natural, intuitive, and immersive experiences. And so what do I mean by natural? Well, as I said, it's about how we interact with the world and how the world interacts with us. So there's no reason that our devices can't do that same thing. Our devices can actually interact with us in far more natural ways, and they can understand us in a natural way so that we don't have to unnaturally interact with them. I think we all have to admit that a mouse and keyboard is a very unnatural act as far as how to touch and interact with technology. So why are we forcing it to do that? Our devices can be a lot smarter than that. The next thing is that we can make these things far more intuitive, by virtue of the fact that it's going to better understand me. It can actually see my face. It can see my expressions. It knows what it is that I'm thinking. It can see the wave of my hand, and it can actually sense my touch. That basically means that we can create interactions with our devices that are far more intuitive. And our devices can also interact with the environment in a much more intuitive way. Through augmented reality and VR and so on and so forth, we can make those far more intuitive by virtue of the fact that they actually better understand the environment. And then finally, and this is where AR and VR has been an amazing thing, they're going to be far more immersive. Again, it's one thing to program totality from the scratch what kind of environment you want to create. But how incredible would it be if our devices could actually understand this room in its entirety and then start creating digital content inside of it? So you don't have to know everything a priori. You could truly create something that's immersive in your world because your world can be sensed by the device in total. The total information could be viewed. So as I said, these devices and this computing power that's on these chips and phones and tablets and the like have been adding sensors over time. We all know that our smartphone has a great sense of orientation. It has a great IMU, so it actually knows its space, its orientation in space. It also has a GPS and interior localization sometimes, so it actually knows where you are on the planet. But sometimes it doesn't necessarily know its space in its immediate vicinity. And what I mean by that, it doesn't really see very well. And so let's start talking about vision. So the visual cortex, the visual subsystem of the brain, has been developing over about 700 million years. And in fact, it's kind of interesting if you actually trace through the biology and the evolution of it, it actually independently evolved in several different places. And basically, for first approximation, they've all developed a sense of binocular vision. All the animals and species on the planet, almost without exception, have a binocular vision. And the reason being, quite simply, is that we, species on this planet, have to move around in a 3D space. And time, of course, if you want to include a fourth dimension, if you'd like. So as a result, it's very important, or was very important from an evolutionary perspective, to make sure that species also have this ability to see in 3 dimensions. And so why in the world do we, for some reason, decide to give all of our devices a relatively monocular, and to be quite honest with you, a dumb viewpoint into the world? There's only so much that you could see from a plane. And again, when the computational capacity was what it was, that was certainly okay. But we're moving beyond that. We got 2 billion transistors on a chip. Let's start using it for some more interesting things here. So one of the first things that we did was we started building some 3D cameras. Now, 3D cameras have been around also for quite a bit of time. The thing about 3D cameras are that you also, in order to make them ubiquitous in devices, you actually need to make them small enough and no power consumption enough that they can actually be integrated in devices. So we have cameras like this. This camera is built to basically fit inside of a laptop and all-in-one and so on and so forth in an integrated fashion. It fits within the power envelope, the thermal envelope, and the size so that it can be fully integrated into a device. And while you're at it, why build one camera when you can build 2 for twice the price? We have a second camera that actually works at a longer range. This camera is really designed for tablet-type usages, and we've actually just recently at CES in Asia showed this actually operating inside of a phablet as well. Again, thermally, power-wise, and mechanically can fit within the confines of a smartphone, a phablet, and a tablet-sized form factor. In both of these cases, they do have an image processor chip built in, so that what's coming out of these things is basically RGB and depth type information. So that's one of the first steps. And that basically takes you to a point where you're like this. So now, you actually can look into the world, your device can look in the world in a much more meaningful way. Not only do you get the color image that you normally would, but you also get a full depth image at the same time. Again, very similar to other depth technologies, but now in a form factor, power, and thermal envelope that allows you to fully integrate into these devices. So that's not really enough. There's a lot of really smart computer vision people in this room, but most developers won't have a clue as to what to do with this kind of information. The RGBD alone, there's probably a small fraction of people out there that actually make meaning of that information. So we also have a software development kit that basically converts this information and, for example, actually converts this data into 22 joints in the hands. So you can actually see the fingers. You can actually point to the screen. You can actually gesture and interact with it. The device would actually know what your hands are doing. Now imagine that for a second in a VR world, for example. Imagine putting on your Oculus, being able to sit down, and then be able to lift up your hands and be able to see your hands working and be able to interact with it in a meaningful way. We also do face tracking. So because, again, we have full depth and RGB information, we're able to do incredible facial feature tracking on a person. We can see 78 points on your face. We can see your expressions. We can even see your heart rate based on this technology. The yaw, pitch, roll, et cetera. So now our device can really understand us a lot better. It understands if we're happy. It understands if we're sad. It understands if we're excited or if we're actually really nice and calm. We even have games right now that are being developed that are actually using some of these biometrics to basically give people another type of engagement with their devices. The other thing you could do is, because I know what's in the foreground, I know what's in the background, because I have a depth camera, I can now segment you out. I can actually segment out parts of the scenes based on the layering of depth and start pulling that into these blended virtualized worlds. AR. AR brings on a whole new meaning when you actually start having depth information along with the RGB. You can really start doing things like occlusion. You can cast shadows. You can actually cast light into these digital, physical, blended scenes in a much more correct way. And in fact, some of these demos are running downstairs in the Intel booth. You can actually see what that looks like. You can actually you can create paint splatter on different objects on the scene, because you, again, have the full dimensional information and not just the RGB information. And then finally, you can truly digitize people. Remember that scene off of Tron where Flynn was actually captured by a laser and actually scanned and brought into the virtual space? Well, we actually now have the ability to do that. You can literally walk around somebody, you can scan them in real time, and you can actually pull them into the digital world. You can pull in objects, people, and so on and so forth. It really changes the meaning of what these blended worlds could possibly look like. So what does it do from an experiential perspective? What does this actually end up unlocking for people by using these types of technologies? Well, first of all, you can capture the world in 3D. We all love selfies, posting on Facebook and so on and so forth. Imagine going to a restaurant, rather than just grabbing a picture, you're actually creating the total dimensionality. So that big, enormous rack of ribs, you literally get to see it in all its full three-dimensional glory to just give you a sense of how big that thing was. And the people on your Facebook feed can actually sit down and actually spin it around and look at it as a full three-dimensional object in mesh, as opposed to just a photograph. So you can literally share things in a much more meaningful way. We can actually bring these things and we can actually, again, virtualize it and put into our worlds, our blended physical digital worlds, in order to make these more interesting as well. We can take people. I can actually scan a person's face. I can actually bring in a Call of Duty, so that way, instead of shooting at random bad guys, I can actually shoot at people that are meaningful to me. Hey, it really helps. It's cathartic, actually, if you know it. You can even scan a full body of a person and then take that full body and actually pull them into the digital space. We were actually showing that in a few demos as well recently. So, again, this whole capturing the world in 3D actually really changes things. You can do enhanced photo and video. Imagine for a second, because of that segmentation algorithms, that you have a virtual green screen with you anywhere that you want. So it really changes the idea of photography. I mean, think about, and videography, think about being able to put stuff on YouTube like a professional broadcaster would, because you have the ability to create really awesome special effects. Immersive gaming, as I said, when it comes to AR and VR, when you start having this dimensionality to the information, you could really, truly create real blended worlds. And then finally, home decor and shopping. Like the previous speaker said, I mean, we have amazing ways by which this can be used in the enterprise space, and we're just scratching the surface in this area as well. But it's a heck of a lot more than just, PCs and tablets and so on and so forth. This camera is pretty damn small, so you can put it in almost anything. You could put it in robots. I saw one of those little robots who are going around the scene where basically you're able to virtually interact with people. Well, you could put these cameras on there so those things actually have collision avoidance. We even took 6 of these cameras and we put them on drones. Now, drones are amazing at telling if they're off the ground and where they are in a GPS perspective, but if I ran one through this room, there's a pretty decent chance on autopilot that it would hit a person. Well, guess what? With this type of technology, this drone could actually avoid people, avoid obstacles, and so on and so forth. I could have a whole crowd of them flying right here, and I can walk straight through them, and they'll actually part away from me in real time. And we've actually shown this happening. So really, when it comes to computer vision, when it comes to AR, when it comes to this entire area, we really are on a cusp. And I think we're just literally scratching the surface between the devices and the other ways by which this technology is going to be used. So thank you very much for the time. Again, it's a really exciting time to be here in this space. We really are trying at Intel to add these human-like senses to devices through use of these cameras, and these are just the first types of sensors that we're working on. There's a lot more human senses that we need to work with. We're working with the ecosystem aggressively to try to develop these applications. Without the ecosystem, there would be nothing in the space. We have to aggressively make sure that we work with our partners in the industry. And obviously, if you have more information, come check out our booth downstairs, or just come chat with me, or check us out online. Thanks a lot, everyone.
So 1 or 2 questions, if anyone has a question. Do we have time? One question.
Tim Merrill from Digi Capital. In terms of your roadmap of adding them into AR smart glasses, what's that look like? And also, what do you see the impact being on battery life?
Obviously, we, with others, in fact, if you actually go down to the RealSense booth, you see us working with glasses and so on and so forth. So anything beyond that, I couldn't tell you anyway. But when it comes to battery life, when it comes to power, performance, thermals, et cetera, that's huge. And again, similar to what we heard last time, it's about creating some of these fixed function capabilities so that we can actually make these things efficient. It's all going to be about efficiency in order to get the power performance down. Now, that being said, we are working on tablets, through phones, through PCs and all-in-ones, and we're getting yes, there will be a battery life impact, but we're still making a reasonable experience despite that.
Hi, Rajiv. Excellent presentation. You didn't talk about the Intel RealSense vest that helped the blind to see, and I was wondering if you could just tell us about it really briefly, because it's an amazing project.
Sure. In fact, I meant to mention that. That was actually one that my team worked on. While you're giving drones the ability to see, why not give that ability to people as well? So we actually had a project that we did. We actually started it about a year ago almost, where we were basically using the RealSense camera. It was actually the tablet version of the camera. And we basically put it on the person's chest. And we specifically put it on the chest of people who had either low vision, specifically retinal pigmentosa, or full no vision. And what happened is this camera basically was monitoring the environment in front of the person. And it would basically calculate and figure out what obstacles were in the way. And then had to feed that information back to the person wearing it. And the way we did that is we basically put vibration motors on different parts of the bodies. So as I'm walking forward, if there was an obstacle here to the right-hand side and it was relatively tall, the right side of my body would start vibrating. So it actually almost, in a sense, get a sense of touch that was extended beyond the person itself. Now what's fascinating about that is if you actually go back to the original Star Trek, there was actually one episode where there was a woman who was blind that actually had a sensor dress on that was basically able to do the same thing. So science fiction is an incredible inspiration for technology. But yes, we've been applying and looking towards applying the RealSense technology to wearables as well, including things that could help the visually impaired.